So good day. This is Jesulonimi, and my project was the Morra project, and it's simply a particular game in which people submit fingers and they count the number. You submit a finger along with the prediction of the total number of fingers that other people playing the game with you would actually submit. Then and you also submit along with a wager, and if you're actually correct, you get the total wager submitted by everyone. So if let's say we are two playing the game and I submit two fingers and I make a prediction of 4, and I submit and the other person submits two fingers and I makes a prediction of 5, I would actually win because I made 2 plus 2 is actually 4, which is the total number of fingers submitted, and I'll take the wager that was submitted by him. So that's just what the Morra project is about. And I did this using the Rich program to actually achieve this. I combined Rich with React, and as you can see, this is my index.rsh file. In fact, this is the project structure of the React project. Actually, this is the folder structure of the React project, and this is my index.rsh file here. So great. So as you can see here, these are particular attributes for my interact function that all players are. First of all, there's a set of random attributes that they are from the rich library stdlib.house random. Then all of them can actually play, obviously, and all of them have access to see who the winner is after several rounds or a round of the game, depending on which particular round we find the winner. Then, as you can see, player 1, who is the person who actually declares contract, is one who will submit the wager. That's all. As you can see, I bring in all the attributes from these all players object that I actually have there. Then player 2 actually accepts the wager, and since here he receives all the attributes of this particular player object that was defined there or interact function defined there. Then from here, this is standard rich code. We actually export our main function and the passing our participants. And when we have 2 participants, participants and participant player 1 and participant player 2. So I'm assuming that there are only 2 players here. Then the first player is seen as A and the second player is seen as B, and as you can see, we actually declassify the wager, we publish the wager, and we actually paid from the first player's account. Then we commit. Then the second player actually accepts the wager, and as you can see, that's what happens from here. Then he pays the same wager again into the contract. Then we also with now we run a particular loop, and we're like while the outcome is 0, because if the outcome is 0, it means that it's a draw, because one day to definitely be a winner in our program. Then we actually get the encoded value that the user actually plays. So that's the interact.play, but as you can see, we did not declassify it like we actually do here. So we actually make a commit to it and a salt so that we can actually publish this commit and salt, as you can see here. Commit the commit actually. So publish the commit so that we can verify it later without allowing the second player know what the first player has played. Because if the second player actually knows what the first player has played, you can just calculate and say, okay, if he played 2, I can play 2 and make a prediction of 4 or something. So we don't want that to happen. So we actually make some checks here. Now this is like security checks here, and make sure that okay, it does not actually know what the original finger is or what the original prediction of the first player is. Even does not know the results, you understand. Then we do similar again we do something similar for Billboard. This time around we'll publish his own finger and prediction, and we use our salts to make sure that the values published there, which was the commit, we also make sure that we commit is right with the correct fingers. So that's why you can say plug finger 1 plus 5 1 comma finger salt, prediction 1 prediction salt, and yeah. So we actually check the commitment to make sure it's this line of code I was actually looking for. So check the commitment using by comparing the commit, the salt, and the actual value. So if this was false, then the code will actually fail. We check the commitment again for the prediction to make sure the person entered the right prediction actually, and it did not change after he got access to the values of the fingers for the second player or this. So that's the point of a commitment is such that we can actually verify that the particular value did not change actually. So someone can make a commitment that, okay,